Okay, so let's remember where we finished. I guess we finished having a typing problem because something should be a type error and it was not. And I guess we even make it an example here. Yeah. So we have a pattern matching with a literal 2, and then we have other literals there, and that should be an error, a type error, right? Do you agree?
Yes.
Okay. So I guess we finish it up with my getters code here, but we didn't manage to solve that, and I don't actually remember what was the solution that you proposed. But I guess you said something about adding the type here. Is that correct?
Wait. What is that function?
This is the function that picks a list of patterns in the guard, and basically does some checking for us.
Wait. That's weird. That's really weird. A list of guards. Well, a list of patterns, but only one guard?
A list of patterns and only one guard. That's kind of weird, isn't it? Oh, this is because this is being used in the fold. Yeah. So let's backtrack a little bit. Let's
Yeah.
backtrack. Okay, so we have this function called fold infinite primitives that actually don't that it is calling that function infinite result there. Right. So this function is probably being used in here. So if you have we apply the function is infinite primitive, right, which is this function up here. And if this returns for us right, that means that we have something that we need to do primitive infinite style. So then we call the infinite primitives. This fold function is a monadic function, so it returns a result. That's why we have a fold m here. And the initial state of the thing is a tuple in which we have an empty list, which I'm assuming is the list of patterns, and we have the unsatisfied thing, and then we just pass
Yeah.
the list.
That's something really weird there, Lemos.
What?
The write is returning the type, right?
Yeah.
The type is information that you need in order to say that the patterns are valid for the given type.
No, but that's exactly the problem that we overlooked, right? And I even said that. I said, dude, we are ignoring the type that is coming from the right. And then we tested and it worked, but then when we did a test that should not type check, it also worked. It said, oh, this is fine, but it shouldn't be. So that's the first cache that, and you are in fact correct. We need actually to put what?
Oh, wait, dude. What was the thing that you tested and worked out?
Um, I think it
Like the
was.
perfect case, no?
Yeah, exactly. It was like a number, and then we have the p variable, like the label for it, and we have the integer itself, and then oh, it worked, and indeed it did, but
That was too naivety.
no, but that's exactly why later I said, dude, I want to test something because I think not having the type information in the fold function will allow other literals to be okay, and it did
Oh.
happen. So.
Hmm.
It did happen. So that's the first gotcha. We need to get this type information and pass that to the fold function, I guess. I'm not 100% sure. But let's start. So do you agree that this infinite result here, or these two functions here, that interact with the infinite primitive stuff, they do need to receive the type, right?
Yeah, they do.
Yeah, okay. So let's add the type here, which is going to be totally okay because then we're going to add this, do
Okay,
that,
uh, uh, can
that's
you
okay. And now I have this, so I can just make type
wait? Let
prime.
me read that again. What is this check satisfaction?
It is just a function that picks a satisfaction output, and it checks if you ended up unsatisfied. It's going to throw an error saying that couldn't satisfy exhaustiveness with this list of patterns, and if you are satisfied, it's going to do nothing about it.
Why do you need to show the list? Could not satisfy exhaustiveness with. That's
It's just for it to
this.
be a little bit easier to debug. It's not necessarily the error message that you're going to end
Oh,
up with.
okay, I see, I see.
So yeah,
Yeah, so the only thing that matters is this fold infinite, and then he uses the other, right? The infinite result. Okay.
yeah. So then the question is, let's read again the fold infinite primitives. For me, this is pretty intuitive. This thing for me makes total sense.
What?
This entire line here. We
Okay.
check if it's infinite. If it is, we do a fold with the patterns starting from a known, like unknown list of patterns, like empty, because we're gonna use that as an accumulator. And we're also gonna have the unsatisfied, and then everything will end up with the satisfaction stuff. And you're gonna pick the satisfaction with a second, and we're gonna check if we are satisfied or not.
Sure.
Okay, so let's go to the fold infinite primitives now. So when you have a primitive, there's only three possible options, right? You have a wildcard, you have a variable, like a name, or you're pattern matching the literal itself, right? Does that make sense? Hello?
Wait a bit.
Okay.
You are saying when it's a primitive.
Yeah, when it is what we are calling a primitive, which in this case can only be three, integers, rationals, and strings.
Oh, okay, it's more specific. It's the infinite kind of primitive, right?
Yeah.
You are saying not the only things that can match, but the only things that. Wait. Okay, the only things that can match, you said, right?
No, everything can match, but if you match anything aside from these three possibilities, you're gonna have an error. So
Okay.
so
Mm.
the yes, that's what we're doing. So if you have a wild card and you don't have a guard, we're gonna say that we are satisfied. That is what this is saying. But if you have a guard, then we're gonna check. We're gonna say that okay, we're gonna save the previous patterns, but we're gonna say that we are unsatisfied, and the same goes for variable, etc. And then there's the gotcha. The gotcha is the literal, right? Which is this guy here. This is when you're trying to
Wait,
specifically
wait,
pattern
wait.
match the value.
The thing regarding we adding stuff on previous patterns only matter when it's not fulfilling already, right?
When it's not fulfilling.
Yeah, that's why you are not adding like the variable one, the wildcard one, because it doesn't matter, right? For example, uh, how can I say like it matched? How can I say? Yeah, just saying that sure the variable matched, but you are not adding to like the previous patterns only because it doesn't matter, right? Because
Yeah,
well,
it
you
doesn't
don't need
matter.
to
Yeah.
check that in the next ones. Okay.
Okay. The only one that does matter is the one that you're trying to pattern match the literal itself,
Yeah.
right? So I guess this is where we're gonna have to go and put the type prime.
Oh,
Yeah, that's that one of the annoyances of the new LSP. But that's okay. So then
so
like
let's
that.
see. You got the literal. You got the guard.
Yeah.
Uh, Again, we talked about that before, I guess. But what does the guard influences in that case? I remember we had some.
Yeah, we had a discovery, which is this case here, that if you have a guard that is just something, we're just gonna return the unsatisfaction, which is exactly what we did here, right? Here and here. If you have a guard that is not a nothing, that means that you're gonna return unsatisfied, and that's exactly what we are doing.
Oh, no, wait. The discussion was regarding adding or not on the previous patterns, right?
Adding or not?
Yeah, because take a look.
No, no, that's a
Uh,
different discussion. I
well,
agree that,
that's
that it is an important discussion to have.
okay. So what is was the one that you were talking about? Because I didn't got it.
The one that we are talking about is the because we overlooked the fact that you can have any sort of literal in the pattern matching of a literal of an infinite primitive.
Oh, you're talking about the problem that. Oh, okay, okay, yeah,
Yeah.
yeah.
So that problem that you said about saving or not saving the guard, that matters, but that will matter probably later. So what
Yeah,
we
but
are
we
going
are doing that already, right? Uh, if it has the guard, then we return unsatisfied. But
we're not
right,
saving
with
it.
it, yeah, we're not saving it. But if there is none, then we are adding it, right? Depending if it was there or not.
No, we're not adding the guard. We are adding the pattern.
Oh, yeah.
Yeah.
There's no
Okay.
way to add the guard.
Okay. So now what we need to do, right? What we need to do, we need to say there was I remember saying something like, dude, we're gonna have to call type checking. And then you said no, we don't because there's another way, easier way of doing that, but I don't remember it at the moment.
Yeah, it's just that you need to check if the pattern that you have there match with the given type. In this case, it's even like easier because you can just do something very specialized, right? You can just check if the literal. Wait, let me see what you are receiving. You are calling infinite result. It gets a type that we just added.
Yeah.
It gets a
It gets the
literal.
literal that you try to pattern match.
Okay, that's like the inner thing of a
Yeah.
literal pattern, right?
Yeah.
Uh,
It gets the
then the
previous
list
patterns
of.
because we need to
Oh,
save
okay.
it.
That's previous patterns.
Yeah, and it also receives a guard because then we can abstract out this case here.
Um, yeah, that would. Oh, okay. Now it makes sense that that type signature, even though it's a very weird type signature.
Oh, for sure.
Uh, so yeah, the thing you need to do is, depending on what can I say, you need to just match the literal and the type, right, to see if they are like valid with each other.
Okay, so we're gonna make another predicate, which is, I don't know, is literal type for now. That you're gonna receive a type, it's gonna receive a literal, and it's gonna receive output a boolean.
Yeah, in like an ideal world or in a I don't know a function that would be more general and maybe make more sense. But I don't know if we if we would actually use it. Would be given a type and a pattern, right?
Exactly. That makes
But
a
let's
lot
do
more sense.
yeah. But we can do specialized for now because I don't even know if we are going to use
Yeah,
the
the
predicate
more
with the pattern.
yeah, the more powerful version. So if you have a t integer and you have a literal L integer with whatever, that means that you're good. Uh, then the other case is when you have t rational and you have L rational here. So that's always also going to be the case. And then we also have the t string one, t string. So, and then we're going to have an L string here. And then everything else is a fail. Is literal type, this, false.
Let's see levels in the typing marathon. How is the
Uh,
typing marathon going, Lemos?
what do you mean by typing marathon?
Well, this is more typing than thinking, I guess.
No, but we already thought about it. That's why I can only like do like this. So if is literal, we are fixing the error that we had last time about you're trying to pattern match a literal, like a value that is a literal, and then you use like I don't know, the literal is an integer, and then you try to pattern match a string, and our type checker will say
Oh,
that's
yes.
fine, and then we're gonna say no now.
Yeah, I remember.
Yeah, we got that error, which was hilarious now that we think about it, but okay. Um,
You didn't follow my advice, right? I assume
which advice it was?
disabling the type checking in the
Oh, of
Spatula.
course. Yeah, that's never was never gonna happen. Then we
That was
do.
easy.
Uh, then we also gonna have an else, and the else will be throw an error. So throw error prime printf, and this will be actually a type error. Um, expected pattern of type this, but well, we don't, but got something different. For now, that's gonna be the message. And then show type this. Okay, does that seem right, Nata?
What you did?
I created a function is
Mm,
literal type, which is
mm.
basically matching. If you have a literal of integer and a type integer, we are good to go. If you don't, we are not good to go. And in the case that we are not good to go, we're gonna throw an error.
Wait. Why doesn't that only happens on the case of you not having a guard?
Oh, you mean that we should have it here?
Like if it doesn't match, like nothing else matters, right?
That makes sense.
Nihilism. Wasn't even that funny, man. What the heck?
Well, it was funny because it was out of nothing. Like we were talking.
Nathan said like nothing matters, and I said nihilism.
Okay, let's see if this compiles just fine. Stack build. What are the odds?
Now the odds have increased.
Just because I get to started singing, that's great. Okay, it did. So let's check our stuff.
You're becoming a human compiler, Lemus.
How how are we testing this? I forgot. I guess,
We had an expression there.
yeah,
Yeah.
we had this, and then we just call. Do we already did you, are we calling type checking?
I don't know.
Let me double check that. Check exhaustiveness. Oh yeah, it is complaining about not being exhaustive. That's okay. Um, type check declarations. We don't have a type check declaration. We have a type check. We have a type check expression. That's what we need to do. Okay, so it's going to be type check expression. Then the expression itself, which I believe I call test sample. And you also have something called typer initial env. Couldn't match. Are they backwards? I'm guessing they are backwards. Test sample. Uh, and there's a problem that I don't recall how I solved it last time. Oh, it was like this. I'm pretty sure. Yeah,
It's good that it
yeah, it
has
didn't
history,
work. It didn't work as expected.
but found something different. Yeah, okay.
Okay, so now that we made this
It
happen,
would be better printing what is that something different, right? But
yeah, but that I think we would have to call type checking the literal, right? Am I crazy?
I don't know where you're handling it.
Here. Like we are handling like this. We are passing the integer to the function infinite result, and this is the literal. And then we made a function that basically compares, uh, like binds one to the other. Like if you are an integer, the literal should be L integer, and so that the reason why we cannot say got something like and got something another thing is because we would have to type check the literal, right? But
Mm.
I think we should be able to do that with the prelude. Am I wrong? Hello?
Can
People?
you
Thinking.
repeat?
Yeah. So in my books, as far as I can tell, we should be able to just call like literal type, call type check expression here, put the
Wait, wait,
env
what do you
here.
want?
We want to get the type, the different. You see here, but got something different. We want to know what is the different, right? So that's what Margita asked. And the only way to know that, as far as I can tell, is to know the type of the literal stuff.
Yeah.
And because they are literals, my guess is that we can just purely just call a type check expression with the initial prelude and we're going to be fine.
Why do you need the initial prelude? It's a literal. You don't have variables there.
No, I need an initial prelude because that's the only way to call the type check function.
It is weird if you don't have a way there on the internals to call the type check without the initial env. But yeah, if you really want type check there, you can do in any way, like with or without.
Yeah, we can just do map empty. Not like that. Uh, like this. Map empty because we don't have variables there, as you said. And if that's the
I
case,
mean, don't you have the printer for? Well, if you have the printer for that type that has a literal inside, then you have a printer for the literal, right?
then I have a printer. No, but we don't want to see the literal. We want to see the type of the literal.
Give me the show function of the type
Give you the show function of the type.
on the literal case.
In the literal case,
Oh, okay, because they don't use the literal, right?
yeah, we don't have literals in the type.
I see. But what about what is the show of literal? Do we have one?
Yeah, for sure. Show literal. So the L integer, we're just gonna show the integer, the rational, and the same goes for everybody else aside from the strings because the strings
Oh,
we add quotable quotes.
oh, I see, I see, I see.
Yeah, so we don't have the well, if you don't want to do like that, we can just say like expected pattern of type this, but got I don't know. We can change the error message to be mismatched types between pattern of pattern of type this and literal this. We're not gonna say exactly, but it is better. So show literal. Yeah. So we have these two options. So what should you guys prefer? So mismatch type is between pattern and of type this and type that, and then we show the literal type like this. Or it is enough to just have the literal itself. I think I prefer having the types. So if you
I don't really like have a huge preference, but I would say that showing the specific patterns make more sense in the sense of, oh, this pattern here is invalid for that type, right? It's more specific than like type mismatch.
oh that makes sense as well. So mismatch type is between pattern of type and pattern this that has type that.
Wait, but pattern twice, but you don't have two patterns on comparison.
We do have two not type patterns in comparison, right? You're right. So mismatch types between value, I guess, of type that and pattern that has that. So it would be like this. Mismatch type between values of type integer and pattern, and then it shows the literal that has type string. I think that's the best that we can do at the moment.
Yeah, I guess that's like give all the information.
Yeah. Okay, so but now we fix the type checking for infinite primitives. And huge thanks to Mageta to helping everybody's last time.
I don't know if I helped with anything, but okay.
Oh, you already forgot, but you did. Okay, so now the question is, we still have other stuff to pattern match, right? Because this is only for infinite primitives, which is integers, rationals, and strings. We still have a lot more to do. So we did the unit, right? So this is the unit one. We did the boolean. We also did the boolean, which I don't know why it is complaining. Patterns are not exhaustive. So what do you mean? So something in here is wrong. Patterns for function prime. So patterns not matched. We don't have a catch-all. Yeah, we don't have a catch-all. That's the problem. So we are missing some cases in here. I'm guessing are these two. So let's add those. Oops. So let's add those two here. Let's put ignore the list. And then later on we can see if this makes any sense whatsoever. That. And then that. Um, what is the problem? Couldn't match that with that. Oh, that makes sense. So I actually do need in this one the previous patterns. And then we can just previous patterns in here. Okay. So does everybody remember what the boolean does? Because I don't.
What do you mean the boolean does?
Yeah, so if you have a wild card without a guard, that's okay. If you have a variable without a guard, that's also okay. If you are unsatisfied with anything else, oh, we need to add the ones that you have a guard. That you do have a guard. Oh no, that's when we discover that you can do the case. Yeah. So you can just do it like this. You can just do it like that. Yeah, I'm gonna have to copy paste later the other cases because well we don't have disjunctive pattern matching unfortunately. So what's the next one? And then we may do the case here and then everything is fine. Actually you can even call the function here. So check satisfaction. That function needs to receive a list and also receives a satisfaction. And then all of these can go. Okay, so what's the next one? We need to do for every single one of them aside from um, some specific ones. Let's go up here. So let's go through the ones that we did. Those. So which one you want to go next, Nathan?
We have the sum cases, right?
Yeah. So let's actually put this here. So the some cases are the TI jailbreak. Is that the one that you want to do?
Yeah.
Okay, shouldn't we do the easier one first, like the list and the anonymous record?
I don't think the list is that easy.
Hmm.
Anonymous record. Magenta, do you remember the situation about the anonymous record? Like,
Uh,
can we do it after?
oh, if you can bind, I don't.
I like
Anonymous records, I don't
pattern
think
match.
you can. No, you can't. Anonymous, you can't.
Oh, that's
Do you remember the explanation?
incorrect.
Because I think they give one.
I think it's because you need a type predefined before, so it knows that the fields are valid when you are adding it. I think we sent the examples here.
Okay, so they know the fields.
Yeah, like for example, when you define a record, like you know the fields that it constructs, and you can infer that this collection is part of the type record A, let's say.
But they also know that for the anonymous record, like its own type.
Well, if you just want to bind one element of the record, I don't think you know. But if you want to bind all of them, I think you can.
Wait, I will take a look on the documentation because I remember they say the reasons.
We sent code here. Let me test. We have some here.
Okay, but for the moment, I will put the anonymous record as an error if you try to
And
print a
you
record.
also said the list, right?
Yeah, the list. We also have the list.
That's indeed one interesting.
Okay, so can't pattern match unknown moves records.
The list.
Yeah, the list is only holding a maybe as far as I can tell.
What do you mean?
Yeah, the list, the type list only holds a maybe type. I don't actually recall the reason for that, but we are only holding a maybe type for the
Oh
list.
no, I was thinking about how to pattern matching stuff. But man, let's do the sum first because like I have on my head
Eureka moment.
uh I wouldn't call that, but I think I know how to start it.
Okay, so let's do it then. So check exhaustiveness. Um, oh, actually, this needs to be infinite primitive that, and the same will apply to this. So if you have a T algebraic,
Oh, okay, they have here limitations with pattern matching. Anonymous records do not support pattern matching, unlike named records. There are three reasons. Holy shit. So let's see. A pattern would have to account for every field of anonymous record, unlike named record types. This is because anonymous records do not support structural subtyping. They are nominal types. Not a clue what you mean, man.
Nominal types means that
Yeah, I know the meaning of that.
yes, but I don't get the subtyping part.
Yeah, so let's see the
Okay, what
second.
is the other reason?
Because of one, that is, why do you say that? Yeah, there is no ability to have additional patterns in the pattern match expression, as each distinct pattern would imply a different anonymous record type.
Mm,
can you send the link where you're reading this from?
Probably
Yes.
on the GitHub, right? On their design.
No, that's the documentation of a shot.
Microsoft?
Yeah.
Oh, so that's why it's bad written.
I don't know. Maybe it's well written and we don't know.
Yes. Maybe we're just dumb. I don't know.
That's always a possibility, but with Microsoft,
Yeah, like when we reach the time, we can try to do it. Like,
Okay, the third one, I don't think it's a reason. Because of two, any anonymous record pattern would be more verbose than the use of dot notation.
I guess one can even question any pattern matching for like, oh no, no, makes sense because you want like nested stuff and specific values. Yeah, it makes sense for records. Yeah, the third doesn't seem to be a reason, dude.
Yeah, it is just like, oh, it was ugly. We didn't like
Because
it.
because if you
Yes,
can,
no, which is a reason, right? I guess.
yeah, but if you can, like considering the other reasons, then you have the same reasons as you have the normal record. That I guess it's a valid case. But about the sum case, then, what I was thinking is the following. You have the sum case, right?
Yeah.
And they have a limited amount of constructors. right? And inside that, they have a list of patterns, right?
They have a list of patterns. Yeah.
So how do we know when everything is fulfilled? We know. Yeah, we know either because someone used a catch-all case, right?
Yes.
Or because you listed every single case of that type, right? Of that sum type.
Yes.
And the first thing we think about is the basic one, right? You have to be listing the case without the guard, right?
Wait, I think that's the point I should start typing stuff.
No,
So,
no, you need to pay attention. Uh, so again, I will talk about the basic case and then a specific case. So we have a sum type that has multiple cases, right?
yeah.
So the ways you can match that is by either using a catch-all cases, right? Then it will
Yeah.
be satisfied.
Yeah.
Or you need to list every single case of that sum type to be satisfied, right?
Yes. That's
And
yes.
every time we match one of the cases, we'll add to the previous patterns, right?
Yes.
To be added there, first, they need not to have a guard, right?
Yes. Also yes.
And the thing is, and that's the specific, the important piece is they have the name of the constructor and they have a list of patterns. In order for that constructor to be added in the previous patterns, all the inside patterns need to be satisfied.
So you call the function recursively on the list of types.
Not quite. I would
Oh.
need a fucking drawing to explain that properly.
Well, feel free, open Paint and share your screen.
Paint on Linux.
Yeah, GIMP. I'm sorry.
What the
Oh
fuck?
man, Apple
That's awesome.
added a drawing thing. Finally,
Magenta,
I have a
Magenta,
Microsoft Paint clone.
Magenta. That's crazy, man. I would just open the browser.
Oh, of course, you would just open the
Of
browser.
No,
course.
no, it's not even for the meme. It's not even for the meme, dude. You have some great tools like Scala Draw, right? Hmm. But yeah, I will not draw them. But
Uh,
the thing is,
so you're screwed
let's.
for life, dude.
Huh?
You're not gonna
What?
draw. You're depending on imagination.
No, no, no. You are depending on my imagination.
Yeah. That's not
So,
a good place to be for sure.
what do you mean? But hey, so let's do the following, right?
Okay, go.
You agree that for each case, it can appear like multiple times, right? Because of our conditions. What I
Yeah.
mean by that is, let's suppose the result type, right?
Mhm.
You have two cases, the left and the right, okay? So the left could appear multiple times, right? Depending on how
Yeah,
you are
totally.
doing stuff.
Yeah.
Yeah. So the thing is, and the patterns would appear in each of the cases that the left appeared, right?
Yeah.
So we can kind of group all the places where the patterns of that position of the left appear, and on that we call recursively.
Yeah, but that's what I thought. If I didn't say
Wait,
that and it was not clear, sorry, but that's exactly what I thought.
okay, I thought you were saying on the list that was inside the one case. Like, you see that that's kind of like horizontal?
Man, not drawing this is a missed opportunity.
Okay,
We
let
should
me
draw
fucking
it.
draw that.
We
Let me
should
fucking
draw
draw
it.
that.
Because this is so like high level imagination for like too big of a brain. I don't have that.
I will fucking draw that.
Oh man.
There's a quote from, what's the name of the dude? The British philosopher. Forgot his name. George Scruton. He says, "Imagination is our last sanctuary." So you better use it, man.
No, that's from the video, right?
I
The
think he
video that you
mentioned,
sent?
yeah, but it's from his book actually on the beauty.
Oh, okay. Yeah,
So,
that video
okay,
is pretty good.
take a look on this on the chat.
Wait, you're gonna take prints of the drawing?
Oh
Yeah.
man, dude, what are you hiding, Nathan? What the heck, man? Everybody knows you
There's
watch
no way,
the.
dude.
You don't need to worry about that, Magita. Uh,
Dude, just
so,
share the tab. I don't
no,
know.
no, 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 I can't right now.
What the
But
He's
crap?
afraid of sharing. He's afraid of showing that he's on Windows, man. That's why he doesn't want to be ashamed.
There's gonna be a slideshow via Discord chats. What the
yeah,
heck?
yeah. So,
Oh, we can
Lemos,
draw on Discord, man.
huh?
We can draw on Discord, can't we?
Oh, those activity stuff? I don't
Let's
know.
see. Oh no, there are games,
YouTube, know
chess,
your meme. Oh,
poker.
sketch hats. Is that a game?
Um.
That's a game that you can draw.
Okay, so let's
Well,
open the game and draw
No, no,
there.
no, no, no. That's bullshit. I'm almost done.
That's bullshit. You want to do a slideshow in the chat.
No, no, because it's almost done.
Okay.
So you see it there, those are like cases of patterns, right, that I have on my branches. Okay?
Okay,
okay.
but the left is the capital A there, right?
Yes,
Okay.
yes. And ABC are like the internal patterns, right?
Yeah.
So what I understood is you saying that I will get ABC and run a function on it.
Yeah, but that's what I meant. So that's wrong
Yeah,
then.
so
So
that's wrong.
what do you mean then?
You get the A and the D, and then the type that they are. Then you have a type and a list of patterns to do the function recursively.
Wait, why the heck the A and the D that you're saying is the non-capital ones, right?
Yes.
Okay, so why would you want to to group the A and the D and call something with that? Would you want that?
Again, the important part. You can only add the capital A, and that was a bad choice now that I see of repeating A.
Oh, of course, but
But
it is totally your style missing that.
yeah, but the capital A, we only want to add that on the previous patterns once all the internal patterns are fulfilled, right?
Yeah.
And for that, we have to check if each of the internal patterns are fulfilled, right?
Yeah, but
So
you
that's
okay, go.
so okay. Let's suppose the first place of the capital A is an int, right?
Mhm.
Then you have to check every time the capital A appears. You look at the first position, you get whatever pattern is there, and you need to keep adding on to see if it matched like the int type requirements, right?
So
You
you
see?
group them vertically, but you walk horizontally, I guess. Does that make sense?
I don't know what you mean by walk horizontally, but yeah, you group them vertically.
Let me think about that. So let's suppose that you have a mismatch amount.
By the way, so just one thing first. I haven't considered yet how does the guard interact exactly with that, but I suppose it should not be nothing too hard. Go
Okay,
on.
but let's do another example of that, right? So you have ABC as like three different patterns inside the capital A, right? So let's suppose that you have only two things inside the second capital A. You only have DF, for instance. You don't have the middle there. How are we gonna
Like
get around
error.
that? Yeah, that's
No,
an
no,
error.
no. Yeah, that's an error. Like,
Yeah, but how are we gonna discover that?
what do you mean, dude?
Yeah,
That's your.
I don't
That's
know what
easy,
you
isn't it?
mean. We are not saving sizes of lists anywhere.
No, 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 man. That's simply seeing if the type of the thing that we are matching, the feeder, match with this pattern. The way we can see that is we have the type, we have the pattern, oh, we see if it matches. Like that's no secret.
I don't think you got the question.
How do I know if this is a valid pattern if it only has the D and the F, like only has two?
No, that's not what I asked. What I asked is how, because we're gonna group them vertically. So if we are group them vertically, what happens if we have mismatched length lists? That's my question, right?
Between capital A's?
Yeah.
That's not possible.
Then I don't know what you're talking about. Yeah. Then I didn't
Because
understand your
the
steps.
constructor A takes a n amount of like children, right?
Yeah.
So yeah, it will always be the same n for the same capital A, otherwise it's an error.
No. You didn't get the
And
question
it's
then.
easy to check if it's an error.
I don't think you got the question. So can we go back to the
Okay.
code here?
Yeah.
Do you agree that capital A or left would be here?
Capital A or left? No. That's the type. Okay. Yeah. Yes.
Wait.
Yes, the text there is the capital A.
Yeah. No, but
But
this is the
remember, you are on type, not on patterns.
exactly. That's what I was about to say. I need to remember that this is only for types, and we are talking about patterns. So I should actually go down here. But
Yeah,
it's gonna be
doesn't,
the same argument. So let's
yeah,
just
it
go
doesn't
there.
have a difference.
Okay. So here will be the left, right, or the capital A, and here's gonna be the lists of A, B, C, and D, E, F, right?
Yes.
Okay. So the question is, how are you gonna know, right, that you have a left with three things inside, or you have a left with two things inside?
Well, we know because we have the pattern. How do we know that someone is wrong? We compare against the type.
Oh, I see what you mean. So the type it will tell us. It
It
should
demands the kind of pattern he accepts, right?
yeah, I don't know if the kind of pattern, but well, it does actually. You're right. It demands the sum type pattern, right, or the wildcard or the variable. Uh, but it actually does have enough information for us to say that oh, we need to have three things there, and now the type is saying that, but you only have two, so that's a problem. Okay, I think I understood what you said. So, but I don't think we finished. So let's suppose that okay, we are grouping them vertically, right? So the A with the D, the B with the E, and the C with the F. And for our future selves, right, or for anybody that is crazy enough to watch this, I should replicate this piece of art on the code. So he's talking he's talking about doing like this, right? And then we have he's suggesting I'm grouping them vertically, right? Vertically.
By the way,
Holy crap! How are
uh,
we gonna do that?
all the naive implementation of that is not really hard, uh, but it's really bad code-wise and error report-wise. Like the smart way to do that, I have no idea.
Okay, but let's continue. Let's suppose that you group them vertically.
Good title, actually.
Let's suppose that you have you group them vertically. What are we gonna do with that?
It could be an architect critique, man.
So you agree that you have a list of patterns, the things that you grouped,
Yeah,
and you know the type of the first position inside the constructor A.
yeah.
Then you have a type and a list of patterns. You can just call recursively.
Yeah, but what is that doing? Like, what is this meaning behind grouping them vertically and etc.? Oh man, I see.
If you return like satisfied or not,
Holy
right?
crap! No. But this is kind of like weird because look at this. When you
Hmm.
have a match of something like match V, the things that I'm gonna use some arbitrary notation just to make my point, right? So when you do like this, we go like line by line, right? Like we apply the function to
Guess
check the
I guess
exhaustively
you're
like
calling
this.
out the error report.
Wait, what?
And go on.
Okay, so this is interesting because when we do the first outer pattern match, checking for exhaustiveness, we go on the patterns like this, like we iterate line by line. But then, if you have a sum type, we group them and apply the same behavior vertically. So it changed the direction of the thing.
I don't know what you mean by direction.
Yeah, what is the direction
We
of doing
still
the pattern
go
match? Is
line by
this,
line.
this? No, but we are grabbing the lines, that we are grabbing the patterns in a like, I don't know how to describe this, but in one move we do this, in another move we do this.
But
Like,
is that something
Okay.
important or just interesting, Lemas?
it's just
Okay.
interesting.
Just
Okay.
one disclaimer here. I'm feeling like I am in my old chemistry classes where I didn't understand anything about like spin of atoms and things like this that I had to use my brain to imagine
Lemus can
atoms.
explain.
I can explain, yeah. So
Okay.
what
Okay.
Nathan's thought, which is kind of genius if you think about it, is the following. So we want to pattern match algebraic ADTs. An
Yeah.
ADT is composed out of a list of names and types, right? So this is a name and this is a list of types. And then you can
Yeah.
have multiple ones. So this is the important thing to keep in mind is that we already have this information. We already have the name and we already have the types that it is constructing with this name. Then the question is, how are we gonna pattern match the sum type? How can we use this pattern right here, right? Because you have an ADT and you want to pattern match to extract the values, right? That's kind of the point of having this pattern is to extract data. It's for other things as well, but in one of the important parts is to extract data out of it. So how are we gonna do that? Let me go back to the example that Nathan sent. So let's suppose that this is gonna be the pattern of a sum type, okay? So the A is this label here, the capital A. I should actually improve this piece of art. So the K is the label here, and we're
Mhm.
gonna have a list of patterns, which is gonna be the ABC, the D, E, F.
Yeah.
The question that Nathan asked the last time was, how do we know that we are satisfied with the amount of patterns if the dude is doing sum types, right? Because if you think about it, we know the case for wildcard and variable. We are always satisfied if you don't have a guard. Like we want to establish what is the case of satisfaction for sum types. Okay. I,
So I think it's, let me guess. So I think for if you have a guard, it's the same.
yeah, you are
And if
unsatisfied
you
if you
don't,
well, I don't know if you
the
are
wild
satisfied,
card
but
doesn't matter, right? Well, it does, but if you only on the sum type as well. But on the elements of the sum type is just the length, I guess.
no, but that's a gotcha. We need to check the length. That's important because we need to check if you have the same amount of patterns that we have the same amount of types in the T algebraic up there. But
Yeah.
another thing that we need to do is that this function is checking for exhaustiveness, right? So we need to see if we're satisfied in the sense that all the minimum required amount of patterns is here. And then what Nathan thought about it was, okay, what about after checking the length, after checking that, oh, the type K requires three things, and then you have three things in there, that's great. But what about doing like, how are we gonna know that this is enough? Like, and this is
You
enough?
know that it needs to be variables and wild cards.
No, but let's suppose that you don't want to use a variable or a wildcard, right? Let's suppose
Hmm.
that you want to check for exhaustiveness and type check at this and type check multiple. I don't know. Let me put a more real example for you. So let's suppose that you have a left 2. Let's suppose that you have a left 3, right? So how do you know that you are okay with these two lefts, exhaustively speaking, right? You covered all the possible cases. Let's put, I don't know, a maybe, so a nothing to have only two cases, because numbers you have infinite amount of cases, right? So let's suppose that you have a just, I don't know, satisfied here. Okay. So how do you gonna know that, right? What Nathan suggested, as far as I understood, is to pick the internal patterns, the list of internal patterns, because you're gonna have a left and a list, a left, a list here. and then you're gonna bind them vertically. So you're gonna pick this pattern, the first position. So let's put, I don't know, another nothing here just for the sake of example, and nothing here. You're gonna pick this nothing and this just, and you're gonna call recursively the same exhaustiveness function that we are doing internally.
Yeah, I get that.
And then you're gonna do that for the second with the seconds, right? So you're gonna bind them vertically. And that's the way that you're gonna know that you have fulfilled all the minimum required amount of patterns for being exhaustive.
Okay.
So the thing that I was doing a comment on is that when we call the function to check exhaustiveness in the beginning, we check like in this manner, like we grab this one and then grab this one and so on. So the way that we grab the data is like from the left to the right, each line. But then when you're doing some types, we check vertically, like the mouse goes here like this, just down. It does not go like from left to the right. And I thought it was interesting to see that it changes the direction that we are doing the thing,
Lemos,
which is weird, but okay.
a few things. Like regarding the guards, I guess we just inherit the ones that like we are in. So let's suppose you are on this left, right?
Mm-hmm.
And you are grouping the internal patterns to do your stuff.
Mm-hmm.
Then you will just get the guard of the branch that you are in. Like for the recursive call also. You just inherit, right? I guess.
Oh no, wait. But what if you have multiple guards? How are you gonna inherit that?
Multiple guards, what do you mean?
Yeah. So let's suppose that this branch is doing like that. And again, arbitrary notation. And then I'm gonna call it true here. I don't know.
You always have one guard for one branch, right?
You always have. Yeah, but what if you have mismatched? You know, like.
No, because what is the signature? The signature is you get a type, right? And a list of patterns that each of the pattern has or not a guard. By the way, that will also require us to change something. It's something that we should have changed already. It's the type signature of when we are doing this stuff, we don't need to know what is the expression like of the actual branch, right? For example, on line 19, you see line 19?
Down, you mean?
Yeah, down.
Yeah, yeah. What's the problem there?
So take a look on the triplet of pattern, maybe expression and expression, right?
Yeah.
We need to just get rid of the last expression because first of all, we never use it. Second of all, it will actually get in the way on the recursive call, right? Well, we could just pass it also. Yeah, just pass it also. Just inherit also, yeah. But we never use for anything, so.
Um, okay, another question that I think it's important. I understood your point, right? So this branch here, which is this expression, we never use it. I said that previous session, but then we didn't. We don't want to. We didn't want to map this thing here and remove it. But anyway, that's not a problem. We can remove it. My question is, when the heck we're gonna check for the guard though? Are we gonna check it in here? In like the exhaustiveness check? Because if you're not gonna check, we can just replace this with the boolean.
Uh, I don't know what you mean. That can always be replaced by a boolean. You
No,
were saying
no, that's not the
checking
case. That's
in
not
the
the
case of
case.
type checking?
If you're gonna do something with this expression, this can't be a boolean. That doesn't make sense. If we only gonna use the maybe functionality, we're gonna always ignore the expression inside it.
Oh, you're talking
Then,
about checking if the guard is actually a bool?
yeah.
Oh, okay, yeah. I don't know where we are going to check this, but if it's not there, you can just use the boolean indeed.
Okay, but this is gonna take more time for refactor, so I'm not gonna do it right now. So I think it's clear that we're gonna, man, how are we gonna do this transformation? Let me think about that.
Oh. You can just do lists, right?
You can do a fold, right? You can definitely do a fold. Oh, but wait, there's a function for that. I think it's called transpose. Uh, Let me go to data list and grab and see if we have. I'm pretty certain we have a function that does exactly that. It picks a list of lists and
I mean,
returns a list
like
of lists
if you are
transposed.
going to do in the most, the first thing is everything that we are going to do will result in some like not so good code
Yeah,
and some
definitely.
weird report error. Like
Yeah,
the order of the report error will be like really weird.
yeah.
But if you want to do like really naively, you can do something simple. Like you go to the
Okay, so
uh,
look, 1 second. Look at this. See?
not quite.
This is binding them vertically. You have a list of 1, 2, 3 and a list of 4, 4, 5, 6, right? Then you want to bind the 1 with the 4, the 2 with the 5, and the 3 with the 6.
Yeah, I don't think that works for Islam.
I don't see how, but okay, we can discuss that later. I'm pretty
Uh,
certain it's transposed.
mm, uh, so yeah, a really naive way would be go into the list, see if all the patterns match with the type, right? So that same kind of function that we did with litrus, but now would be more general, right?
Wait, you're talking about which list?
Well, the list of patterns with branches, right?
You mean the list of patterns with branches? You mean this list here?
Yes.
Okay.
Uh, yeah, we can go to that list and just see if the type is, well, if the pattern is valid for the type, and we see that for the whole list, right? Then
Yes.
it's easy for you to do a filter on all the constructors that are left, right? And then you map, getting all the first pattern, you see?
Getting all the first. You mean the p sum type?
Be some, like getting the first slot of the case of a given constructor. Like I have the list, then I filter to get all the patterns that has the constructor left,
Yes.
and then I map to the internal pattern of the left.
I think I got it, but I think it's going to be so much easier typing it down, so let's do it. So what is the first thing that we should do? You said that we should pick the list of patterns and improve the function up here, the is literal type. So I guess we're gonna transform this to um, is what? What's gonna be the name of this function? Not the
I don't know, man.
Just for me to understand, you want to make a function that picks a type and a pattern, right?
Mhm.
And returns you a boolean.
You,
Yes. So for now, I'm gonna just call is pattern type. So let's suppose.
you can start with the easy ones, right? Match the pattern, and you know the catch-all cases match any type.
Yes. So the catch-all cases would be the p wildcard. This is always gonna be true, right?
Yep.
Another one that's always gonna be true. Oops. Is the variable, right? We are not talking about disjunctive. So is pattern type. Now we need to go one by one, I guess, right? Or do we need to call recursively the p sum type? Whatever. Well, if you receive a list, an empty list, that's false, I guess. That should never happen in the case of parsing. But that's okay. Then you pick the first one. Then
Wait, how?
how?
Wait, what is psum type again?
Psum type is a label and a list.
Okay. Why is
Pattern.
that false?
Oh, because this is an empty list, right?
And
Should we... What does it mean to have a psum type in which the patterns are empty?
like none.
None.
None only has a label.
Oh wait,
Of
so we
course.
do need to care, I guess.
Yeah, leave this some type like for the for the end, but it's not very tricky.
Okay, so you want to do... No, but let's do it right now then. If you have a
Okay.
psum type and you have an empty list of patterns, what do you do with that comparison?
So you have the type there. So you first need to check if the label is inside the labels of the type, right?
No, but then you're saying that this type needs to be a algebraic, I guess.
It is.
Okay, and then you're gonna have a list here, right? Um, and then we need to grab that list. We need to map it. We only care about the names, right?
Yeah, you need to do the following. You need to do a find on that list
Yeah,
to get the case that has the label that is the same as the psum type label.
yeah. Find, which I already forgot the signature.
Can you see the type of the list?
Can I see the type of the list? What do you mean by the type of the list?
Well, you have the list variable there. What is its type?
List. Oh, I do. It is a list of tuples. Like that I know.
Uh, let's see.
Here, we just care about this name, right?
Yeah, yeah,
Yeah.
yeah.
So it's a find, and then we're just gonna go to, because I already forgot the type signature. But I guess it's find and then the thing, so it's gonna be the label, right? So find label labeling names. Then what is the psum type? That's a text, and this is a list of text as well. Let me double check the signature here. Um, oh no, this is a function. Okay, okay. So if this returns nothing, what does that mean? We didn't
Means that
find.
is already wrong, right? It's already a false.
Okay. If we find it, what does that mean?
Oh, okay, you map it first to only get the names. Okay, okay. If you do find it,
Yeah.
now you need to check the arity, right?
Mm, wait, you need to check the arity, you say?
Yeah, because like the thing that you got. Oh shit! I just typed something by mashing my. Because you will get the label itself and you will get the list of types, right?
Yeah.
So yeah, the first thing is like remove these empty lists from the line two up.
Wait, remove it?
Yeah, I just got a variable there.
Okay.
Uh, so
Well, I guess I'm gonna call this types then.
yeah, I guess you might have a like a really good function to do that, but something you can do is check if like both lists have the same length, right? And then you need to do the recursive call, right?
Okay, so if length of list is equal to the length of patterns, if that's the case, we're gonna, if they are equal, this is true then, right?
No, no, you still have to check, right?
Check.
The patterns that are inside, the type that is inside, check if they match. That's the recursive call.
Ta, 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 ta. Wait, now I am really confused. So
For
you're saying,
example, the option, let's suppose we have an option int,
mm-hmm,
right? So we have a pattern that carries a string, right? But the type is option int. So we need to check if the int match the patterns of like a string, right? So you see that you have a list of types and a list of patterns.
yeah.
Just call recursively the is pattern type.
Call recursively in the function itself. That's what you're saying, right? Like call it using binding each one of these with each one of these, I guess.
Yeah.
Okay, I see what you mean. So how the heck I'm gonna do that? Because we have lists, right?
Yeah. If you have that operation on two lists that take a predicate on the pair, that would already like give you the check for arity, right? Because yeah, it's something weird, but in the last case,
It's very weird what you're asking.
yeah, if you don't have a function for that already,
Can
I
you
guess you
repeat?
can.
Can you repeat for me what this function is supposed to do? It receives a predicate in two lists. Is that what you want?
Yeah,
And does what with that?
and returns like true if all the predicates on the pairs like of elements of the list matched, right? If they have different lengths, that's a false. You could zip the thing and then map that using the pattern type, and then if see if all are true, right? You could do that, but
Oh, that works. That works.
I'm taking a look on the Okama library because maybe you have something like this.
Maybe you have something like that.
Yeah, I know you have a section on iterating on two lists.
Okay, but just a sec. Just a sec. So how do we check if every single... I already used this function before, I just don't remember. Check all true in list. I think I have a way to do
Dude,
that.
take a look on that. Take a look on that, dude.
You guys do have it.
It probably
Damn.
has in Haskell, man. What is
Damn.
the for all of Haskell? Like, how do you call predicate on every element of the list?
Wait, but I think we can make it even better. Okay, so this is gonna be all equal to true, and this is the naive version, okay?
Zip width.
And then I need to send. Holy crap!
Oh, that's a zip in the map?
Yeah. And then I need to send the list of patterns. So this is gonna be patterns. But
Expecting a joke with zip, but I didn't hear any.
and
Wait.
then we also need to get rid. We need to get rid of the. Holy jeez. A
But is
list.
that something that you map before zipping? Because
That's what you use to zip. Like you combine them instead of zipping with a tuple function. You combine them with this.
oh, I see. So the normal zip is zip width passing the
Tuple.
tuple, right?
Yeah, yeah, yes.
Oh, okay.
Yeah, but that should be about it. So then if you have an else, if the lengths are not the same, this is already false, right?
Yeah.
Yeah, so is pattern type undefined. Okay, okay. So what about that? So what is it complaining now? It's saying that the found, why not? Yeah, that is indeed another way of doing this function. You guys saw that? So it's saying to do
Wait, I was
this.
not paying attention. What was that?
So HLint said, instead of doing this if, what about doing this?
Oh, uh, I guess. Yes.
You guess, right?
Yeah, by the way, why don't you look on Google, man, the type signature?
Let me check Google. Let me just uh, and do those here. Okay, Google. So the function, the type signature of that is grab an A, grab a B, and Google is talking right now.
Trying to help you, dude.
Uh, okay, based on the type signature, we don't have that here. Um,
That's uh,
yeah, but this function is pretty specific.
I don't know. I will take a look on data.list.
Okay, go on there. Okay, in the meantime, so let's try to understand what the heck is going on with this guy. Wait. Oh, I see. Remove that. Remove the dollar and put it like that. Okay, that kind of works. Oh,
Special folds.
what do you mean?
They have a section on the data.list that they call special folds.
Oh yeah,
That's
it's.
a weird way to say it, but that's true, right?
Yeah, for sure. Anyway, so let's continue here. So we already know how to grab the psum type, the p variable, the wildcard. Are we missing anything?
Wow. All the types?
No, no, all the types. But do we care? Should we just make a catch-all with the false?
Of course we care, man. That says if a type and a pattern like are compatible.
No.
How are you not doing that for the others?
Well, because we are. Well, that's kind of. Okay, I got your point, but it's gonna be just annoying. But okay.
You can literally just use the is pattern type on the other place you are using the is literal type. Like, because it's more general, right?
No, I can't because I'm gonna have to change this literal and wrap it with a p literal. And well,
Wow.
that's kind of annoying, but okay. So let's grab that. Let's put it in here. Um, so this guy will be pattern, right? Um, actually, I should do that. So this p literal, and then that, like that, right? Everything else is false. Is that correct?
I don't know. I don't know what is left. What are all the types?
We have
Like, is
the
there any type left?
yeah we
Left
do
too?
yeah we do have the oh, we are missing the unit one. If you're gonna make a general, so we should actually put. I think we have L unit, right? Yeah, L unit. So let's remove all of that and just say that this is a unit, and the T unit will also enter this party. Yeah, it is indeed a lot more general than the other one. Okay, so are we missing any literals? Unit, integer, rational, string? No. Are we missing any important types? We only care about T unit, T integer, T bool. Oh, we don't have bool here. We should have booleans. So L bool, whatever. And you can just do it like that. T bool. Okay. T string. T list is not gonna do it at the moment. T anonymous record you cannot pattern match. We're not gonna do the. I don't think you can pattern match the other ones aside from the T algebraic. Is that right?
Yeah, maybe you can.
Okay.
Yeah, for now we just don't.
Okay, so let me just wrap this guy. Um, and this guy would be is pattern type. Yeah.
And we can have a data dot lists with the S on the end,
There
but
is
it
a
doesn't
data that
have.
lists.
Yeah, but I think it doesn't have what I want.
There is a data that lists. Yeah, your function is pretty specific. Oh wait, there is a. Oh no, but this is not
There
the
is
same.
extras and split. Maybe one of those has me.
I think this is good enough for now. So what we are doing this function y again? I already forgot.
Because like naive way of grouping the things is first going on a first check, see if all the patterns are valid, then doing filters, map, and etc.
Okay. So the first thing that you're saying is that okay, you have the type algebraic and you have the list of patterns. Uh, well, we don't actually have the list of patterns, right? We need to map this guy, but we're gonna get there. So the first thing is to make a let, well, an if, and then you're gonna have to zip with again. Is that correct? Yeah, because this is a type and this is a pattern, and we have a list of both of those.
Wait, let me see where are you?
Check
You
exhaustiveness
are.
for having the algebraic type and the list of patterns and guards and branches.
Wait, what part are you writing right now?
I'm writing the verification. Well, that at least that's what I want to write.
Oh,
Uh,
from the beginning.
yeah,
So yeah, that's some nasty code. So take a look.
yeah.
We can do for like one imaginary case for now, and then we generalize. Uh, but yeah, you first to do that. Uh,
Yeah, and then you do if this.
that
Oh,
that list is the patterns.
but
Well,
patterns with the
patterns and branches
guards
and
and
guards.
yeah, yeah.
Yeah. So yeah, I
Okay,
see. You first.
We already verified those. That's what this if is doing. It's verifying if everything is okay.
Okay. Since you are verified, now for every constructor in types, you have to go to the list, filter by it. Holy shit, dude. That that's some terrible code. But you see where I'm going?
No, let me repeat. So we're going to go through the list of constructors inside this.
Types, yes, the labels, right?
Yeah, we're going to go through them. And for each one of them, we need to check something with the patterns as far as you said. I don't know
Like
why we would be
for
doing that.
no, I didn't say that. For each one of the constructors that we have inside types,
Yeah.
right? We
Yeah.
have to do one operation. What is that operation? Is to get the list of patterns and guards and such, and then filter by the one that has this constructor, right? And then we
Right,
have a
but
list
how are we
of
gonna?
pat.
Yeah, but how are we gonna filter patterns
Well,
based
the
on the
labels,
constructor
right?
name?
Well, we have one label on types, and we
Yeah.
have another label on lists.
Oh, the piece some type has the name.
Yeah.
Okay, but let's do that
So
then. So let.
wait, but once you did
No, no,
that,
no, no. Let's stop right there because then I'm gonna get lost. So let's call this something. This will be a filter, right? This will be a filter. We want a function called filter map, I guess. Is that a function or I am going crazy? So Hugo, do we have a filter map? We do. Okay. Yeah, no, but it's not doing what I imagine. Okay.
you want the opposite,
Map
the
filter.
map filter. Yeah.
Okay, but is that a thing? Do we have map filter? Yeah, we do.
Why wouldn't?
No, 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 wait. No, no, this is not this does not do what we wanted to do. So let's go part by part. So what is going to be the filter? Let's go with no, the filter is the last important part. So let's go with the first on the types. Okay, so this will give us a list of constructors. So these are constructors, like that. Then for each constructor, we want to use it to filter. So this is going to be filtered. So we're going to map with a filter. Yeah, constructors. And then the function that you're going to receive is a filter on top of the patterns. Is that correct? Yeah. So, holy crap. That's some nasty code, yeah. Do you see how this is going, Anton?
Yeah, I'm thinking about some other problems, dude.
Oh, you're thinking about other problems.
Yeah, yeah. Because take a look, man.
Just a sec. Just a sec. We have multiple patterns, right? Yeah, I don't think we have a way around this. I need to.
You need to pattern match, right?
Yeah, I need to get out of this thing. Okay,
Huh?
so um, is some pattern. Um,
No. If that returns a boolean, that doesn't help you.
that helped me, yeah, because then I'm gonna receive a pattern, and then I'm gonna
Oh
receive.
no, then the name is totally off.
Okay, the name is not the best, but I am focusing on the functionality. So if you have a constructor,
This is the worst excuse I've ever heard.
what? Focusing the functionality first?
Oh, dude.
Is some type. Um, then we're gonna have a label, and we're gonna ignore this list. This will be this, right? And then everything else, um, I don't know, match, maybe, yeah, match is definitely better. Okay, so let's do it then. So match some pattern. Okay, and then you're gonna return false. Okay. Then this filter is now very okay because it's just a matter of doing match some type C. Okay. Okay, now we're gonna have a list. We're gonna have a list of lists in which each individual list is the patterns that match it. Okay, Nathan?
A list of lists.
Yeah. Because we have a list of constructors, right? Then for each constructor, we have a list of patterns that match it.
Okay, I see.
Yeah.
Uh, yeah, it's not exactly a list of lists, right? It's a list of tuples that inside the tuple you have a list, right?
No, no, it's not a list of tuples. If you want a list of tuples, you want something different than what I
No,
did
wait.
here.
The patterns? Can you take a...
Patterns, yeah, patterns is just a list of patterns.
Oh, you're already mapping the thing.
Yeah. Then, for each constructor that we grabbed from the types of the algebraic here, right?
Yeah, that's a problem because you also need the guard, right?
Holy fuck. That's getting nasty, dude.
Yeah, it
Getting?
is.
It's
What
getting
are you talking
even
about?
worse than I thought.
And yeah, you need to stop a bit first to talk about a few things because that might end up in a place where we don't want. Because take a look, dude. We are doing all of this, and by this, we will be able to check the things that we talked about previously, right?
Yeah,
But that might have a problem regarding the order in which we are checking stuff.
regarding the order.
Yeah, and as
Okay.
we do know, order matters when type checking pattern match.
There's matter when checking pattern matching. I agree. Um, okay,
Like,
so
what
type
is the
field.
moment for us to check that, right? Because,
Uh,
for example, let's suppose you are doing only this, right? And right on the beginning, you are not checking anything else, and you are checking only on the beginning. Then we are ignoring everything regarding catch-all cases and where they happen, right? So doesn't
yeah,
really work, right?
yeah.
Just a disclaimer, I just noticed I left the F sharp auto completion on the background. It's consuming 3 gigabytes of swap.
You saw on my journey with that, right? You guys remember the trouble that I
Yes,
had.
I do.
Like literally, it was breaking
Dude,
my
like I
computer.
man, this is stupid.
Oh, dude. Ugh. Is that it? Is that what you want? No, that's not what you want. I need a list of what? I need a list of types, right? I don't have a list of types. Anyway, go on, Nathan. Go on.
But I already said it.
Okay, so repeat the last part.
Yeah. So let's suppose we
Mm-hmm.
are only doing this check, right? This check that we haven't finished, but let's suppose it's done. We are only doing this check, or at least we are doing it on the beginning, right?
Yeah,
So you see that we are ignoring, for example, the catch-all cases and where the catch-all case appear, right?
yeah.
So yeah, it's a problem. We cannot just check that anywhere. We need to know where to check this properly, right?
Where to check the catch-all case?
No. Um, the checks that we are doing is getting all the constructors, right?
Mm-hmm.
And then seeing if uh, the internal ones are fulfilled and such and such. But that doesn't say as much that
That
no,
does
it's
not
not.
say as much.
Yeah, regarding if the actual pattern matching is being okay or not, right? Because, for example, in cases where you have the catch-all cases, right? It means that this stuff there would fail, for example, right?
Mm-hmm.
So, yeah, and in the cases that it succeeds, but you have a catch-all cases after or before, then you have some like cases where it should instead give you a warning, but it would not, right? I'm
Oh,
not
you're
sure
saying
if
you're
I'm.
talking about that the order in which the wildcard appears or the catch-all cases appear, they do interfere with the whole judgment of the thing.
Yes, but the main point is the judgment that we are doing right now should maybe happen and in a specific time or place, right? And I don't know exactly.
You're talking about the judgment of the constructors stuff.
Yeah, all the idea and such, right? It's maybe not required to happen and should happen in a specific time, I guess.
Oh, I think I know what you mean. So the order in which we check stuff alters the final, like the way that the user sees the warning or the error or whatever.
Yeah, and
That makes
yes,
sense. That makes sense.
but uh yeah, and when I was thinking about this, I already knew that we would have problems regarding the order in which we reported stuff. But now that I'm seeing, it's worse than that because we can even like miss some errors, right? Like given when it shouldn't, or not given when it should,
Wait,
instead of just
wait. What about that? Like, I totally understand what you, now that I like reflected a little bit, it makes sense. The order of in which we check stuff makes a big deal. It is a big deal. But I suggest that we should focus on doing the hard part and then later we just say, okay, what should happen first? Then we just move the blocks of code around.
Okay.
Because if we care about the order now, I think you're gonna get lost fast.
Okay, so you are saying finish this part, right? And then we
Yeah.
see like where should
Where
happen.
should it go? Then
Okay.
we care about that later, right? Because right now we have a lot of on the table already. We are checking the constructor stuff, and we're checking if you have a sum type there. And this, let's finish this task, and then later we say, oh, this should come afterwards after all. Okay. But the code is already there. That's the important piece of it. So let's do you agree, Nathan?
Yes.
Okay, so let's recapture what we have done already. So we're gonna get, we know we have a type on hand, which is the EDT. And we know that we have a list of patterns, of guards, and branch. Then we're gonna separate only the patterns. And then we're gonna see if for that given type T algebraic, we're gonna see if all of the patterns are okay. We're gonna map the isPattern type function, see if all of them return true.
Okay.
Okay. If we do, then we are grabbing the constructors out of the types of the ADT, so the left and the right and whatever. And then we are creating a list of lists.
Wait. Map first on types. Okay, the names of the constructors.
Yeah, we are getting the names of the constructors. And then for each constructor, we are filtering all the patterns that match that constructor name. So we have a list of lists. And unfortunately, this LSP is kind of dumb. It's not showing me the type, even though,
You are mapping the constructor.
yeah.
Yeah, now I see that
So
you're showing the same thing as before, right? The key, like the equal. Even if you hover
Even
with
if
the
I
mouse.
hover, I guess.
let's
No,
find
that's
one.
the. Yeah, pick another thing because this is the. Yeah, filter.
Yeah,
That's strange. Because
not
I
sure.
remember it didn't show on the mini buffer, but it showed when you hovered. So I don't know what happened.
Yeah, that's okay. We can figure that out later. But the point is that this is a list of lists. That's what I want to say.
Yeah, I saw. So for every constructor name that you have the list in which the patterns with that constructor is present, right?
Yes,
So
yes,
let me
exactly.
see. Filter patterns. Okay, I see. I see.
Yeah, but then you said something that broke me entirely, which you said that we need to care about the guards. You see? Well, is that true? Do we need to care? We need to carry the
Yeah,
patterns?
we do, but wait a second. There is something more.
Okay.
Yeah, the something more is also a type, right?
The something more is also a type. What do you mean?
What I mean is that the label that you are getting from the constructor, right?
Mm-hmm.
Like their types. We also need the types,
The types you
right?
mean from the ADT.
Yes,
Ah, I
from
see what you
the.
mean.
So later we can use the mix of a type, a list of patterns with guards.
Wait, repeat the last part. We need a mix of what?
Like we want to do a recursive call for check exhaustiveness, right? By
Yes.
the way, I think that's spelled wrong. I think that is a 8 somewhere.
Yeah, after the X, I told that today.
After the X. Oh, I see. Uh, so and
Oh,
it broke.
dude, no, no, no. Wait,
What?
you are with your cursor like pure and stuff because you scrolled.
Yeah, no, I'm doing Control D now.
Yeah, okay. Yeah, just don't move.
Yeah.
Because I think if you go all the screen.
So here.
Yeah.
Okay.
Uh,
Okay. Go on,
so yeah.
Nathan.
So what is our goal? Our goal is to do a bunch of recursive calls on check exhaustiveness, right?
Yeah.
So what is it taking, right? It takes a type, right?
Yeah, it takes a type. Yeah.
And the list of patterns, guards, and the other expressions for some reason, right?
Yeah, it takes the branch as well.
So yeah, we need all of them.
No, but we do have those. It is in here.
No, no, yeah, but we are like getting out with our maps and stuff, so that's wrong, right?
Yeah, we
Because
need
then we don't
to.
have it to do the recursive call.
Yeah, but then I have a question for you. Then I do have a question. So, do you agree that whatever you're gonna do it, if you're gonna map it here or map it here and be a gigantic line, that doesn't matter. What matters is my question, which is that do you agree that after this filter you're gonna have a list of patterns? Do you agree with
List
that?
of list of
No,
patterns?
no. The list of lists is after the map. I'm talking only about the filter.
Oh, okay.
Yeah. So if you have a list of
Yeah.
patterns, we don't. How are we gonna bind these filtered patterns with the guard in the expression that we like? There's a mismatch in quantity in my mind here. We need to inherit. Is that what you want?
No, no, you see the patterns there? You
Yeah.
are getting the things out, it's just not getting them out.
No, no, no,
And
no.
you
We
will
didn't get
have
the
it there.
question. You didn't get the
Mm.
question. Ignore all the maps that I am doing just for the sake of removing
Okay.
stuff and getting only what I need. Ignore all that. My question is, inside this list here, we have a pattern, a guard, and an expression, right?
Yeah.
Then my question is, after we filter all of those, we're gonna have a list of patterns. We're not gonna have a list of pattern, guard, and expression. We need to You need to grab these patterns and bind them, like glue them to a guard and a branch in order to call
Oh, no,
recursive
no,
this
no, no,
function.
no, 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 no.
Okay, go.
If patterns were everything, you will still filter by the same thing and have the results that you want. They are already bound to each other. There is no
Oh,
zipping later, dude.
oh no,
No
there's no
fucking
zipping
zips.
later. That explains it. That totally explains it.
And by the way, the thing that I always complain about zip and unzip is because if you are doing that, you just need a fucking map, dude. Like, there is no reason to
But you
risk
cannot.
some
But
mismatch.
that's a horrendous argument because you can always translate one to the other. That's not the point.
Of course it is, then. Because what is the risk? The risk of mismatch for some reason.
Uh, Pattern, and then we're gonna ignore this, right? And then the match sum, whatever there, it's gonna be here. Yeah, okay. And then okay, so now we are not gonna use patterns anymore as after this if, right? So it's only for this. It's only for this if all whatever. So oh man, I can't see the type, so that's so annoying. But this is a list of
So yeah,
uh,
the constructors we also don't need to. Yeah, we don't need to map the constructors.
okay, so what
I
we're gonna
guess.
do with that? We're gonna just use types, I guess.
I guess.
Yeah. And then what we're gonna do with that? We're gonna map it, we're gonna filter, what we're gonna do?
Yeah, just destruct first, right?
Okay, so here and then here.
So let's think about. Can you annotate the result that you want, the type of the result that we want? We want a list, right?
We want a list.
Yeah. Okay, better. Let me type the type for you that we want as a result.
Dude, this is a map M. And then we just call check as exhaustiveness in here. Just check this. The first thing that we need is oh fuck, but we have a list of
Yeah.
types. Holy Jesus! So it's a 4M inside the map M in which we have. Then we're gonna call the check exhaustiveness in here. Holy
Uh,
Jesus!
wait a bit, Lemons.
This is
The
like
for
horrendous.
wait, I'm not sure if that's
I'm 100% sure. I'm even
You
going
are
for it.
100% sure.
Yeah, I'm even going for it. Yeah,
Uh-huh.
it
Wait,
type
wait, wait. No,
checked.
that's not how you
Yeah.
ask, Mata. It
Huh?
is. Would you put your hand on fire for these lemons?
Well,
Is
he
what
would.
happened
It
last
doesn't
time.
mean shit if it's wrong or not. It
No,
just means that he
no, but you
thinks.
remember what happened
Holy.
last time, right? He burned his
I
hand.
lost my hand.
So okay, let's go to that. Like, first of all, that's
Holy Jesus.
terrible, but
Yeah, no,
uh,
that's terrible. That's like inception of monadic
yeah.
stuff.
So let's see. We are doing a map on types, right? Types. It's the algebraic internal stuff there, right?
Yeah, it's
And then
this. Let me put it here.
C and TS.
Whoops. This. So each one is gonna be a text, which is the constructor name, and we're also gonna have
Yeah.
this.
Instead of that, let's change the names because C and TS. Holy fuck.
Yeah, C is for constructor, and this is for, well, this is for types, right? Because it's a list of types, but we already have types in here.
Yeah, you are on a sick language, right? Uh, so
No, no, no. The problem
okay.
is that I don't want just. We can change the name of types. Types is out the outer types. This
No,
guy
no.
is bad.
Again, you are on a sick language because they are complaining about the shadowing. Uh, but let's see. Sure, you have the label there, right? And the types.
Yeah.
Okay. So then we have a for, right? On
On the
types.
types. Yeah.
On types.
Yeah.
That has to be wrong.
Okay. No, not these types. That's the problem. We're talking
No,
about
no, yeah,
these
I
types.
see, I see. That's not my problem. So, okay, we go. Okay, let's go on.
I'm gonna
We
call
go from.
constructors this guy because
By
we
the
need
way,
this.
the order is weird, right? You first pass the list instead of
Well, you can use
passing the
traverse
function.
if you prefer the other way around.
Oh,
That's fine.
that's the only difference?
Yeah.
Okay.
Well, I don't know if you have traverse Sam, but maybe.
But that doesn't matter.
Oh yeah, we do.
So, okay, you get the list of types there. And can you highlight where the parentheses end?
Of course. So the parentheses is in here.
Holy shit, man, that's a
Yeah.
lot of parentheses. Okay, so for each type, for a given constructor of the type the algebraic,
Yeah. You see? It's
okay,
madness.
we check for exhaustiveness with that type. Okay,
Yeah.
that's nice.
Yeah.
Uh, and then we pass a list for it. Can you highlight also the?
Yeah.
Okay. So yeah, the things there will be the list. The list is the original list of all the patterns, right?
Patterns,
And
guards, and branches.
yeah, we will filter that.
Using the constructor that is bound to the list of types. That's
Da, da,
important.
da. Let's see.
Holy
They have the
Jesus.
same name. Okay. Mm. Yeah, that's wrong, Lemus. I guess that's wrong.
What is wrong?
Yeah, because then you are getting a list of all the patterns that has the same constructor name.
Yeah.
But then we also need to map that again on, oh, get all the firsts. See?
Get all the firsts. I don't know what you mean.
Yeah, because yeah, you see the for m iteration,
Yeah.
you are on one of the internal types of a given constructor.
I am in the internal types of the given constructor. That's correct.
But the filter that we are doing
Yeah.
is getting all the patterns for a given constructor, but not the internal first pattern, for example. See?
Not the internal first. That doesn't make sense because we don't want a list of patterns, right? We want this, right?
Yeah, but you see the pattern, it would be mapped in an internal pattern. Would still be the same type.
Wait. Now you got me confused. What are you talking about pattern inside a pattern?
Well, that's the sum pattern, right?
No. Yeah, that part I got it.
So
But
yeah.
wait, repeat.
So you have a pattern there that is a sum case, right?
Yeah,
And it has a list of patterns inside, right?
yeah.
It would be mapped to one of those internal ones.
Holy Jesus.
So yeah, you would have lose your lost your hand again.
No. But what I said this time, different than the other one that I lost my hand. I said it was correct. The only thing that I was 100% sure it was typed correct.
Oh, that the type checks,
There's
right?
no fucking way I would look at this mess first glance and say that it's correct semantically.
Okay.
But let's think about what you said. So you said that the list that we want to bind to the guard in the result in the branch is the one inside the sum type.
Yeah, I think our problem is the for there. Like that was too hurry of you, I guess. Uh, yeah.
Okay, so can we go on again on the process that we want to do? Let's start from having the constructor. So we have a constructor and a list of types. Okay?
Mhm.
What we want to do with this information?
Well, I already described how, like, exactly what we want, but the algorithm for it, well, would be
Okay,
us.
explain. Okay, can you please explain again what we want then?
Okay, so we want, uh, like, this thing carries all the constructors in the type and the types it carries, right?
Yes.
So we want for each of those constructors,
Mm-hmm.
right? Constructors like names.
Yeah.
We want for each of them the list of patterns that correspond to that constructor, right? Okay.
Yes.
And then like and they would also have like its guard and its uh, expression, right? The useless expression.
Yes.
And then from that we want to do the
Wait, let me try to repeat what you said. So for each constructor paired with the list of types, we want the corresponding list of patterns in the sum type
has the
that
same
match
constructor name,
the
right?
set that has the same. Let's stop right there. Let's
Mhm.
stop right there because
Like if you eliminate the for m, you already have that with the filter.
I already have that with the filter. No, I don't. I definitely don't.
You sure do.
I
Take a
sure don't
look.
because this is the p. This p is not the. It is the sum type. I need to pattern match and extract the list, dude.
No, wait, man. You see that you have constructor there on the map m lambda.
Yeah.
So that's the label, right?
Yes.
And there you are doing a filter on the list using that constructor, right?
Yes. So what we're
That's
gonna.
it.
What we no. That's not it. That's still not it because what we want. What is the return of this? This will filter the p sum type. Do you agree?
The some type.
Yeah.
Yes, that has the same name, right?
That has the same name. What we want is not the p sum type. We want the list that is contained
No, no,
inside.
no, no. That's another step. Like
Oh,
what I
okay.
said so
Oh,
far
okay. So then you're
was that
correct.
we only want that.
Yeah, so you're correct. So what we want is just
Oh, you
this.
deleted the filter.
Oops. I still
Yeah,
didn't.
and dude, give some indentation, like break the lines.
Yeah,
I mean,
Emacs
on
is
the
not.
body of the lambda, right?
Yeah, the Emacs is not contributing for that happening, but okay. So the filter will go like in here, I guess.
So let's see from that. What do you want to do? And by the way, it's already like 9 and 5, dude.
Yeah, but we started late, so we
So
still have
let's
5 minutes.
see. So let's see.
The
From
result of this
that,
is a list of patterns, right? No, it's a list of lists of patterns. Again, right? We can remove that.
yeah, don't think about the filter thing, right? Think about we inside, like we are still in progress, right?
Uh-huh.
Uh, so let's see. Now I have all the patterns
We
for
have all the
that.
sum types that
Um,
matched the label of the constructor.
yeah, there is a meme here that might get us in.
There is a meme.
Oh man. Oh, we know this case, man. Isn't that that Chinese one that has a weird
I don't
name?
know, but I think it's that. I think it's like Horizon. I don't know. But
I
what
think it's
matters is the
Horizon. I
the
think it's
counts.
Horizon.
What matters are the counts, man. That's what matters.
So let's see. We have the internal types, right, of that constructor name, and we have all the patterns that have the same constructor name.
Yes.
So
Yes.
what do we want to do is the following.
We want to filter. We want not filter. We want to grab each one of these p sum types, and we want to extract it out the list of patterns that they contain.
Wait,
Right?
can you repeat that?
Yes. So let me start from the beginning. So do you agree that this filter operation here will give us every p sum type that matched the name of the constructor?
Yeah.
Okay, from my understanding, we want to go to each one of these p sum types and extract the list of patterns that they contain.
Yeah. And match that with one of the types, right?
And match that. What do you mean by match?
Like, for example, the PSON type, I will get all the first patterns, and then I'll get the first of types. See?
Oh, you mean zip them. Not in
You
the
could
code.
say,
Not in the
you
code,
could,
semantically speaking.
you could say that way, yeah.
Okay, so that's a better way. You're welcome. So
Uh,
semantically, you want to pick that list of patterns and zip with the list of types. Yeah, okay.
wait. So, what is a good way to do that?
Yeah, the
Like,
problem is that we don't
I
have.
can only think about indexes or functions to go throughout two lists that I know we don't in Haskell, I guess.
Oh, even with that, I don't know how the heck we're gonna have to make a function that extracts the thing for us because the, we need to get a way of removing the psum type stuff, right?
Yeah, so do you have, yeah, we need like some function iterations stuff that has an index. Do we have that? Or do we need to want to use a fold and start with the index?
I don't know why we want to do that, but that's a
Because we
possibility.
have to iterate, for example, if we are going to iterate two types, to know what to extract inside the other thing, right? Then we know to know what is the index that we are. Because we know that they have the same length, because we checked it, right?
Wait, I think I lost this later part. So
Yeah.
you what
So we have
wouldn't
the types,
yeah.
right? Ah,
Oh, wait. So for each one of the lists of patterns, we need to bind this. We need to zip the same list of types, right? Ooh, I didn't think
I
of that.
I I don't, not sure if that's it. So let me try to explain in a way.
Okay.
So you have the types there, right? So let's suppose I get the first of types.
Yeah.
Right? Oh, I might have an idea on how to do it. But
That
let's
does
go again.
epiphany moment.
Yeah, but see, you get the first of types,
Yeah.
right?
Yeah.
Then you see the result of the filter, right? You got the list of patterns with the other shit. So of that pattern that has the constructor that has the same name, it has a list of patterns inside, right?
Yes. Also yes.
So I want to map that to the first internal pattern if I got the first of types.
Yes. Also yes.
So yeah.
No, wait. But I don't think you got we got an established understanding here. So I think it's easier drawing. So let me draw up here. So let's suppose that you have left integer string, okay?
That's the type.
That's the type. And let's suppose that you have a p-sum type in which you have left, and then you're gonna have a list of stuff, a list of patterns, right? Do you okay?
Yeah.
Let's suppose that you have another one and another one, right?
Yeah.
So we have this list here, but we
Mhm.
have only one single list of types, right?
Yeah.
So my understanding is that for each one of these lists,
Yeah.
we need to
You
zip
get
them
the.
with this.
Ah, I don't think so. Like again, you want to do on the vertical, right? So if you are on the first element of the list that you are highlighting there, right? You want all the first elements of all the pattern lists.
You want all the first elements of all. Oh no! Oh, I see. I see. I see. I see. Hmm. Dude, wait.
So yeah,
Isn't
a
that
way
just
you.
transpose?
I don't know about transposed, but
No, you still didn't take a look on the function. Oh man. It is
show
trans.
me the function
This
again.
is transpose. What you're talking about is totally transpose.
Okay, so show me the function.
Okay. It is this again. So
Okay.
right. So imagine that this is a list of patterns, okay?
Uh huh.
And imagine that this is a second list of patterns.
Okay.
So each one of these lists is this list here, okay?
Oh, I see a list with all the firsts, a list with all the seconds.
Yeah.
Yeah, that's good.
Yeah, because then we can just grab it, right? Pick the first pattern of this list and the first one of these and the first one of these and group them together as a list.
Yeah, that doesn't work quite well. Yeah, that doesn't work quite well because of the word and the expression, right?
No, that works perfectly in that case as well because this is a list of tuples, let's suppose.
Hmm.
Word, and then you have branch, and then you're gonna have that whatever how many times you want. He's gonna transpose everything with it. It's gonna transpose
Okay.
the triplets as well.
Yeah, the same thing. I see. So yeah, let's do it.
Okay, so so then my understanding is that wait, where is it? Wait. Oh, here. So this is already good enough then because this is a list of
Then you can zip with, right?
then I can zip with. Wait, that part I got lost.
Yeah, after you transpose, right? You
Yeah.
have these lists and the list of types. Then you zip with, right?
Wait a sec. Wait a sec. Okay, I transpose then I zip. But what is the function that I'm gonna zip with?
Well, the check exhaustiveness, right?
Yeah, but then we have a problem because check exhaustiveness is a monadic function. Let me check if you have the zip with m. zip zip with m. Oh my fucking god, we do. I am so surprised.
That's
But okay.
fucking language.
but okay. Okay, I don't know how the heck we're gonna call this. So let's call this some types. Yeah. That's actually called matched sumtypes.
Oops,
Matched,
that's a lot of work.
matched sumtypes. Okay. Then we're gonna transpose it, right? So I'm gonna give I don't know something. This is gonna be transpose matched sumtypes. Oops. Oops. No. Emacs is going crazy. Okay. Um. Okay. Matched sumtypes. Okay. We're gonna pick the matched sumtypes, and we're gonna just transpose it.
You can say you use Emacs by the ecosystem, right?
Well,
Because,
depends.
like, the main reason for it, I think you just don't.
Zip. Check.
We're
The
talking about
part
me.
of personalizing yourself.
This. Then
That's
I need
just
two
that's
lists.
just a side effect, man.
No, that's the main reason because all the others are presenting a bunch of other editors, right? For
Yeah, but
example,
Emacs is not an editor. That's the point.
fuck that, man. For example, if you're talking about keyboard only, that's not a main point of Emacs, right? You can do that whatever. Like,
Oh, it is not. But that was never the point. It is a
but
Lisp computer.
sure, Lisp.
This.
But the reason people can actually sell this, right? Like, for people that are not like
Is that it?
Lisp maniacs, are because you can like personalize whatever, right? With code and shit.
Show
It's like super
more.
powerful.
Redo. Okay. Dude, I
But if
think
you
that's it.
don't use that, it's just for the ecosystem.
Um,
Which, well, is the valid reason.
transpose matched sumtypes.
Clojure will be such a great name for a cron.
Okay, Nathan, let's take a look. Final look here.
I don't
Is it?
want to look at this. I'm disgusting.
But you should. Uh, so for each constructor in the type algebraic, we are going there and grabbing all the psum types that match that constructor. That will give
Okay.
us a list of patterns. Okay?
Okay.
Then we transpose it in order to group together
Wait,
the
wait, wait,
ones.
wait, 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 dude, wait.
Okay.
And then you are putting that on the left, right?
Yeah, I'm putting all of that in the let, what I just said.
Oh. Oh, okay. You are. I see. Then you are mapping. I see. You are using the zip width with check exhaustiveness.
Yeah?
Transposing it. Yeah, the thing there is that you are mapping with second on.
Yeah, I'm doing with that with the constructors because we want to ignore the constructor name. We only want the list of types, right?
Yeah, then you'll be there is something off about this, I guess. Let's see. Constructors.
Constructors is a list of tuples. So let me
Oh,
bring it.
dude.
It's a
Without
list of
having
tuples.
the
Here.
type. Ah. ah,
Yeah, I agree that not being able to hover and show the type sucks.
yeah.
But I will
So
fix that eventually.
give me a second. So those are the ones up there, right? Because before we were calling that types, but constructors.
Hmm. Ooh, I actually need this. Okay, forgot about that.
Ah, so the second. So a list of types. So you have a list of types, right?
A list of types. A list of types. No, I don't think so.
Uh, so constructors is a list of tuples, right?
Yes.
Isn't the second element a list of types?
Yes. Oh yeah, so after the map you mean? Yeah, after the map I have a list of lists of types. Yeah.
Okay. So you have that, and then you have the trans. Not think about the transpose now. So zip width, check exhaustiveness. Can you give me the type of zip width
Yeah,
somehow?
yeah. So zip width is and it picks an A, a B, and returns a monadic C. It picks a list of A and a list of B, and it returns a monadic list of C.
So let me see. Okay. So by the first there, the A there is also a list. So
Yes.
the yeah, so that is something off already.
Yeah, I agree that there's something off. I
Check
totally.
exhaustiveness should not get the list. Yeah, maybe we should do stuff internally there. I don't know.
Wait. List of stuff. Oh, I see.
Yeah,
Yeah.
maybe we should do there inside, right? Because we avoid stuff, I guess, that way.
Yeah, so yeah, but that's not gonna do that today because it's already past the 2 hour mark.
Yeah.
We demanded 2 hours to write down 5 lines.
Yeah, that's a really dumb way to look at it, Lemos. We
I
know
know
it's not about lines.
that's why it is a joke. That's why that especially in languages like Rust and or Haskell or something, you should never take the amount of work of something based on the number of lines. And bye recording. Take care.